what we've been doing in the last few sections is given a function, we've been finding the derivative of that function. So now what we're going to do is we're going to go backwards, and given the derivative, we're going to find the function as best we can. So here's some notation we're going to use. Suppose that f of x is the derivative of some function capital F. Now what we've been using before, right, is given f of x is the function, then its derivative is f prime of x. But what we're going to do now is we're going to say that f prime is we're just going to call the derivative, because that's really what we're working with. We're just going to call that our given function. So our given function is really the derivative, all right? So when we see f of x, we're thinking, oh, that's the derivative of some function. And then that function from which it came, we're going to denote that with a capital F. So if you start with capital F and differentiate it, you get this one here. So for example, suppose that this is the derivative of some function, right? So what we're doing is we're letting f of x be the derivative because that's the one that we're working with, so we'll just call it f. So suppose that 6x plus 4 is the derivative of some function. Okay, what is that function? Well, here's a possibility. That function, and we're going to denote that with a capital F, that function could be 3x squared plus 4x. Just run a check on this. Suppose, as we were doing in the last few sections, if this is a function, what do you get for its derivative? You bring the 2 down and multiply, so you get 6x and then plus 4, right? So given this function here, here's its derivative. Or, in the direction we're going, given the derivative, here's the function. But now, that's not the only thing that could happen here, right? Because it could be that if the derivative is 6x plus 4, then it could be possible that f of x, the function itself, is that 3x squared plus 4x, say, plus 7. Right? If you differentiate this, you get 3x, or you get 6x plus 4, and then the derivative 7, that's just a 0. So this derivative right here could have come from this function or this function. Or, in fact, I don't really need to put a 7 here. I could put any number at all. So, for example, again, if that's the derivative of some function, that function could be, okay, well, we have an idea already. It could be that 3x squared plus 4x plus, now, up here, the constant was a 0. Here was a 7, but it could be anything because the derivative of the constant is 0. So this is just some constant. And the way we're going to write that is this. We're going to say f of x is equal to 3x squared plus 4x. And because I don't want to write some constant every time, I'll just write maybe a capital letter C. We're going to call this, since we get many of them, we're going to call this a family of functions. Now we call it a family because here's like the main part, and then you add this on and you get like the children, right? So here's the parents, here's the children. If it's 0, you get this one. If C is 7, you get this one. If C is 10, you get some other one. If C is -8, you get some other member. So we're just going to call this a family of functions. And so when you take a function like this one and find its antiderivative, you generate a family of functions. Okay, I'm going to read this definition and kind of discuss it as we go along. So starting here up at the top, just as the derivative d dx of f of x, or f prime, symbolizes the derivative of f with respect to x, we're going to use this symbol right here. Now follow it down. It's this symbol right here. It looks like this. If I write it big, it kind of looks like this big lazy S. We're going to use that symbol right here. It's called the integral of f of x dx. That symbolizes the antiderivative, or integral of f of x. So f prime symbolizes the derivative of f of x, and this notation right here, that's the antiderivative, or another word for antiderivative is the integral of f of x with respect to x. So all in all, here's what's going on here. We're going to start with some function, f of x. This is what we did in the last two sections. You start with some function. Now in those sections we called it lowercase, small f. Now I'm just calling it capital F. So I'm going to start with some function f. Then I'm going to differentiate this. So I'm going to differentiate f of x with respect to x. And that is going to get us, okay, I could call it f prime, but now I just want to call it some other function, f of x. So what we're saying here is that you start with some function, big F, you differentiate it, and you get small f. Now it's sort of like you start with f of x and you get f prime. But instead of f prime, I'm just calling it this now. Now what I want to do is go back as best I can, so I'm going to anti-differentiate f of x. And here's how I say that. Take the antiderivative, or the integral, of f of x with respect to x. And when I do that, I get this other function, right, the antiderivative, but I don't get back exactly to the antiderivative itself. I get back just to the family. So for a little example, suppose we started here. Capital F of x, or the function, is, say, I don't want to start there, I want to start here. Say 3x squared plus 4x minus 6. Okay, now that's some function. I differentiate this function, so what do I get? I get, you know what, I could write that like this, f prime of x, but instead of f prime, we're going to call that f of x. So I differentiate it and I get 6x, put an x in there, I get a 6x plus 4. Now what I want to do is go backwards. So I'm going to anti-differentiate that 6x plus 4 with respect to x. The dx tells me what the variable is, and that gets me back to the 3x squared plus 4x, but I don't necessarily get back to the minus 6. I just get back to a constant. This minus 6 here, this is a particular member of this family, right? C could be any number. This is a particular number. So this right here is a particular member. When I go backwards like this, I just get back to a member. Now don't worry how I went from here to here. We'll do that in the next section.